Okay, we're one more example in section 3.5 here, the derivatives of six trig functions. In this example, I just want you to understand that we can combine trig functions with algebraic functions, and using our rules for sum of functions or multiplying functions, the product rule, or dividing functions, the quotient rule, we can find the derivatives of more complicated functions. So in part A here of example 42, I want to take the derivative with respect to x of x squared minus sine x. That just means I take the derivative of x squared, which is 2x, minus the derivative of sine of x, which is cosine of x, so I get the derivative of this guy is 2x minus cosine of x. In part B, I want to take the derivative with respect to x of x squared times cosine of x. So now I have a product rule, function times function. So it's the first, x squared, times the derivative of the second. The derivative of cosine of x is minus sine x, plus the second, cosine of x, times the derivative of the first, x squared is 2x. So just simplify barely, I get minus x squared sine x plus 2x cosine x. In part C, I want to take the derivative with respect to x of tangent of x divided by x. So now I have a quotient rule, right? Function divided by function. So I go low, d high, right? X times the derivative of tangent of x, which is secant squared x, minus high, tangent of x, times d low, derivative of x, which is 1. All divided by low, low, or x times x, which is x squared. Simplify that, I get x secant squared x minus tangent of x, all divided by x squared. In part D, again, I have a sum of functions. I just want to do some examples for you. So the derivative with respect to x of 5x plus secant x, I take the derivative of 5x, I get 5. And then the derivative of secant x is secant x tangent x, which again you just have to memorize. The derivative with respect to x of tangent of x times sine of x. So now I have a product rule, right? Tangent of x times sine of x. So it's the first times the derivative of the second. So tangent of x times the derivative of sine of x is cosine of x. Plus the second, sine of x, times the derivative of the first, derivative of tangent of x is secant squared x. So then, if I want to simplify this a little bit, because sometimes in your homework you need to simplify and put it in its most simplified form, notice that tangent of x is sine x over cosine of x. So sine x divided by cosine of x times cosine of x, the cosines cancel, I'm left with sine x. Secant squared x is the same thing as 1 over cosine squared x times sine x. So I can split that up as sine x over cosine of x times 1 over cosine of x, and that's tangent of x times secant of x. In the last part of this example, part F, I want you to find the second derivative, right? D squared by dx squared of cosecant x. So this notation means find the second derivative. So the second derivative is the derivative of the first derivative. So the first derivative of cosecant of x is minus cosecant x cotangent of x, which you memorize. Then I take the derivative of that guy. I now need to use a product rule. So first times the derivative of the second. So minus cosecant of x times the derivative of cotangent of x, which is minus cosecant squared of x, plus the second, cotangent of x, times the derivative of the first. So the derivative of minus cosecant of x would be positive cosecant of x cotangent of x. So if I bring this through, simplify this, I get minus cosecant of x times minus cosecant squared x is cosecant cubed x, plus cosecant of x times cotangent squared of x. And if I would like to, I could factor out a cosecant of x from both terms, and I get cosecant of x times a quantity cosecant squared of x plus cotangent squared of x.